This pattern for infinite series is not a coincidence. We can generalize this. Here's how. First, let's call the sum of this infinite series S. Then let's multiply both sides by x. On the left, we have x times s, and on the right, well, 1 over x times x is 1, 1 over x squared times x is 1 over x, and so forth. Then let's subtract line 2 from line 1. On the left, we have x times s minus s, and on the right, well, a lot of the terms go away, because we have 1 over x minus 1 over x, 1 over x squared minus 1 over x squared, and so forth. So all that's left on the right side is 1. And when we factor and divide both sides by x minus 1, we see that s, which is what we called the sum of this infinite series, is equal to 1 over x minus 1, which is exactly what we wanted to show. Now, this technique of calling the infinite series s is pretty cool, so let's try it with this one. S equals 1 plus 2 plus 4 plus 8 and so forth, the powers of 2. Then let's multiply both sides by 2 and then subtract. But when we subtract, we get s equals negative 1. This doesn't make sense in the real number system, that 1 plus 2 plus 4 plus 8 and so forth equals negative 1. So what went wrong? Well, we can only use this technique if this series converges, if there's a finite sum. And we can see that 1 plus 2 plus 4 plus 8 and so forth does not converge because we keep adding bigger and bigger numbers. Now let's go back to our original problem. We need to show that this series converges. So I'm going to do this pretty informally. First, we declared that x is an integer greater than 1. So our first example is 1/2 plus 1/4 plus 1/8, and in a previous video I showed that this is 1. So let's take a look at all of these other series. Take note that all of the first terms are less than 1/2. All of the second terms are less than 1/4. All of the third terms are less than 1/8, and this is going to go on forever. So if this infinite series converges, and all of these terms are less than the corresponding terms in this series, then it's safe to say that all of these series converge as well. So I made videos visualizing these three infinite series, and some of you noticed that there's a pattern over here, and we can see that this pattern does continue. Now, if you missed those videos, I recommend watching them to see that we can see why these are true visually.